everybody. Good evening and welcome to Tampa Devs. I hope you're having a wonderful week, and I'm super stoked that you've all made it out. So we've got some great things on the docket today. So I'll start just by explaining Tampa Devs to those of you that maybe have not encountered us before, give you some updates on our programs and upcoming events, and then we're going to jump straight into the main talk. It's myself and Kevin. Kevin, raise your hand.
Hey everybody.
We're talking about DevOps for video games, and it's super, super cool. So Tampa Devs is a community of software developers seeking to grow together, and we are a registered nonprofit. So our mission is to basically help developers and folks in Tampa Bay's technology sector get networked, find success, and just strengthen that whole community overall so that we can have a stronger industry. Very happy that Embark is one of our sponsors. So we're in Embark Collective's kind of meeting hall right here. They are a sort of a startup incubator / startup school of sorts. Tons of member companies in different industries. So if that's the kind of space that you're looking for, definitely give them a look. Upcoming events. So later in July on the 26th, we have a networking event. We also have a Terraform workshop that's coming up, so keep an eye on our meetup page for that. On September 21st, we got DevOps Days, and I'd like to bring my esteemed colleague, Chris Ayers, who is the lead organizer of this event and one of the folks at Microsoft, to talk all about this. Take it away, Chris.
Yeah, this is our third annual DevOps Days, Tampa Bay. This is the only DevOps Days in Florida, and like the next closest one's up in Atlanta. This really is about talking about DevOps in the community. There'll be some great talks. We've got Nora Jones, who wrote the book on chaos engineering, who's going to be our keynote. And we're going to have a bunch of live spaces. So after we have talks and lightning talks, we're going to have a space for discussion talking about like how you can take some of these DevOps principles and concepts from chaos engineering to how to integrate testing into your platforms and infrastructure as code, and how you can apply those back at your organizations. We're also going to have job boards and networking opportunities, and there will be a hot breakfast and then vouchers to hang out at Armature Works where we're having the event. September 21st, if you go out to the DevOps Days page and look for Tampa, you can find tickets. Right now we got early bird tickets on sale, and we're going to have some community codes for some discounts that will provide the Tampa Devs. So hope to see you guys out there. It'll be a great event.
Thank you, Chris. Yeah, keep an eye on our newsletter. We'll be sending out more information about DevOps Days as well as those discount codes to everybody that is on that. We also have Bay Hacks coming up at the end of this year, so this is kind of our flagship event for Tampa Devs. It's our annual hackathon. We're looking at a couple different venues for that, and we'll have more updates to share as those plans solidify. But big round of applause to Matt, who is leading the charge on getting it organized. Thank you, Matt. We also have a mentorship program. So speaking of Matt, why don't you tell them a bit about the mentorship program?
Great, thanks Charlton. Yeah, I know you guys are all excited to hear this great talk about Charlton and Kevin, so I won't take too much of your time, but our mentorship program is growing in participants, and we are looking for more mentors. If you've got 3 or more years of experience, we'd invite you to please join. It's simple, it's only a couple hours per month with the person that you're mentoring, and it really makes a huge difference in guiding them forward in their journey. I know when you start, it's like, where do you go? There's so many options. So please, if you're interested, it's a great way to give back to the community. Part of the mission of Tampa Devs is elevating this entire area, and this really makes a big difference. So please scan that QR code, and we also have a link down below. I'll be here at the end of the talk, so if you have any questions, just come find me. Thank you.
So, some other places you can find out about our programs on the web. We have 882 people in the Tampa Devs Slack, so if you haven't already joined, this is a great place to hang out, ask questions, network with folks. We also have a page at tampa.dev that's a list of all of our different partner groups and communities, so if you're looking for other excellent technology-centric meetup groups and user groups in the area, this is basically a one-stop shop to point you at many of the best ones. We also have a store. If you want these cool shirts, we got all kinds of shirts. And if you want to support us, we have a link you can go to donate. We have a GitHub if you want to contribute to any one of our, we have about 30 different open source repositories now. and we're on these various social media platforms. We also just launched this really cool thing. So I know, I see at least one of the folks that's currently using it. Alex, how you doing? So this is a reverse job board for developers in the Tampa Bay area. We have about 40 folks on here right now, and we just launched it like a week ago, so that's pretty fantastic. But basically, if you're looking for work in the Tampa Bay area, we go out and we make a bunch of different partnerships with different recruiting companies and other types of companies in the area. And they look at this basically as an excellent resource for finding like developers in Tampa that they can then hire for different types of things. So it's completely free to make a profile, and basically when you get hired, we get a small commission, and that supports our programs, and it basically keeps Tampa devs running. So helps people get jobs, helps us stay in the black. And so I know a couple people in here have actually already signed up for this. So we're going to give you free shirts. And then at the end of the month, we are going to do a drawing for a $100 Amazon gift card from the pool of active profiles on here. So best way to enter that drawing is to make a profile if you are in the market. So without much further ado, let's go ahead and get close to the main talk here. If you want to give a talk much like Kevin and I, please do email us at speakers@tampadevs.com or go to tampa.dev/speak. And now I will hand it over to Kevin. Here's a cable.
1 second.
It's okay.
Can you move your laptop? Thank you. Give me a moment here, guys. Okay. Ooh. So, thank you guys for enlarging this PowerPoint. Thank you guys for having me. Hello. You probably, oh, what the? Yeah. Give me a moment, guys. Charlton, guys. I could use some.
Why don't you introduce yourself a little bit while I fix this?
Yeah, as he said, my name is Kevin Brown. Professionally, I work as a 3D animator. But just recently, me, Charlton, and Cameron over there, we all worked on a game called Ibis AM, which you're about to see.
There we go.
There you go. Hello again. This is going to be a tech talk. It will be, I promise. But the first thing we have to do is we have to talk about fish for probably an uncomfortable amount of time. And the reason that is because Ibis AM is we like to call it a immersive fishing simulator, where you play as a starving bird who has to constantly eat fish. I'm going to quickly play the trailer here and probably adjust the volume on the go. Music will come on, I swear. The music might not be on, but I'm just going to crank it on my laptop. So yeah, that's Ibis AM. If that didn't make too much sense, that's okay. It didn't make too much sense as we were making it. But to talk about where that game came from, it started as a Ludum Dare game entry for the Game Jam. And if you don't know what a Game Jam is, it's essentially you only have a few days to completely start and finish a game based on a prompt that they give you. The specific prompt for this Game Jam was every 10 seconds something happens. So I took that as, okay, every 10 seconds this bird is just going to starve and he has to eat fish before he runs out of health. The Game Jam ran from September 30th to October 3rd. Those dates are important because if you remember what was happening at that time, you can probably understand I was not able to finish the game in that amount of time. But what this did kind of do for me is very quickly I had to throw together a like super simple and still convincing fish AI in that short amount of time. And that's what's on the agenda for today. I'm going to give you guys a tour of the Godot game engine by recreating this simple fish AI I had on day one. We're going to go through one of the levels in the game so I can illustrate just kind of how Godot structures its entities. And then at the end, Charlton's going to dissect the build pipeline he built for me, and we're going to release an update live to Steam. So without further ado, this is my, I don't think I'm going to be able to hold this mic and do this. Yeah, I'm not going to be able to do that. It's okay. I'll try to project my voice so you guys can hear me. We're going to quickly open up Godot and open up the project. And right off the bat, if you've ever used a game engine before, like Unity or Unreal, you'll probably notice how, I guess just how quick that was. Just how quick that was getting into the game engine. The thing about this game engine, it's an open source game engine, which means the community kind of builds it, meaning there's not really a lot of bloat and there's not really a lot of things that bog it down. I think it's a 60 megabyte game engine, whereas Unity might be 2 gigabytes, or I don't even want to think about how big Unreal is. But let's quickly play our scene and see what we've got going on. So this is currently our game as it stands. There's not too much going on here. There's a beautiful little yellow square in the center, and then there's a slightly less beautiful squashed square on the bottom. I can hit 1 to replay the scene, and you can see that the yellow square is actually a physics body, meaning we can pick it up, throw it around, and I was gonna say that this isn't very fun, but I am enjoying myself a little bit just throwing this yellow square down. But I think we can do a little bit better than that. So right off the bat, you'll notice in the center we have the 3D viewport. That's how we can see what's going on in the scene. And to the left is just the itemized version. So you can see we have the main node, that's just everything. We have the environment, that's just the ground. And then we have our box, and that is the physics body. So really quickly, I'm just going to get rid of the box. And I'm going to hop in here. This is at the bottom, this is the file system. This is where all the files that you're going to use in your game are stored. And I can grab my fish mesh and plop him right here. And he just looks great. Next thing I'm going to do is, I'll direct your attention to the right here. This is if you're used to Photoshop or any Adobe program, this is like the properties panel. You can change his scale, make him really big, or we can shrink him down. And actually, I might fatten him up a little bit. I don't like, if we hit him from a side view, you can see how skinny he is. So let's fatten him up. And then over on the left, I'm going to come in here again. And this list that I just brought up, this is the list of all of the types of entities you can make in Godot. And I'm just going to quickly add a collision shape to them. And what that's going to do is it's going to allow the fish to interact with the environment we had set up previously. And I'm just going to shape it correctly. This takes 2 seconds, but I'm a little bit nervous here with everybody watching me. Usually I do this alone, just in the dark of my office. But yeah, so now sorry. Just trying to fill in the gaps. So we're gonna play the scene again, and you can see it's still essentially the same thing as the box was, but objectively it's a tiny bit better. We can shake the fish around, get him to jiggle.
Is that animal cruelty?
I don't think it's animal cruelty yet, but it will be in a second.
So is that a model you got from like a store?
Yeah, it's just a 3D model. I rigged it up. That's a good question.
I asked about the rigging, like how it bends and flops. Like, was that part of the model, or did you do that?
Yeah, so in the 3D software, I just rigged up the tail a little bit, and what you're able to do after you do that is you just kind of lag it behind the rest of the model. That's why when I shake him up and down, you see his tail kind of does that. Pretty great. Thank you. But yeah, I didn't finish typing the word fish, so I'm going to finish that now. And then the final tab we're going to open up here is we can give them a little script. So I'm going to write fish demo in all caps, apparently. I already wrote that script. We're going to name it something else. We're going to name it fish test. And you'll notice, I'll talk a little bit about the scripting language. I'm a little out of my ballpark here. So Godot uses a custom scripting language called GD which is, from what I understand, it's a Python-like language. If you don't enjoy that, you can also use C# in the editor as well. Other than that, I can't say much about it. I'm just here to make games. I don't care too much about the language. But I'm just going to get rid of the boilerplate really quick. And we're going to write a quick function here, not in all caps. We're going to say func, we're going to call the process function, which just essentially means this is something that's going to run every single frame that our game is active. So in that, I'm going to type out self.linearVelocity equals vector3, parentheses 0, 0, and -1. And let's just see really quick what that does to our guy. You'll see now he's just constantly moving to the left. And that's because, like that. And we can stop him a little bit by like kind of putting him on the edge here. But he is just going to constantly be trying to move that way. And that's because when you're working in 3D, coordinates are, in 2D you usually have the X and the Y coordinate, the red and the green, so we can go up and down, left and right. And in 3D, we have a third axis. And essentially all we're doing here is saying, on that third axis, just go forward 1. But we can do a little bit better than that. So I'm just going to quickly nullify that. But to do that, we need a few variables to do that. So I'm going to write var spawn position. This is where the fish is going to start. I'm going to write var goal position. I'm sorry if I type slow. And we're finally going to write a new function that is func generate, we'll just say pos, generate pos. And what we can do here is, this is where we're going to define the goal position. So we're going to do spawn position plus a random vector3, random dot vector3, and it's going to be in between a range of -1 to 1. So just on any axis, it can be anywhere from between those two. In our ready function, I'm going to define our spawn position. So spawn position equals this jargon right here. This just essentially means position. So self.globaltransform.origin. I'm sorry about my spelling again. Origin. Or thank you. Oh, damn it. Sorry about that. And I can actually zoom in a little bit, an uncomfortable amount. So self.globaltransform.origin, and essentially all that's doing, if I, in the ready function, also call my generate position, I'm going to throw a little debugger here, which is just essentially a red dot that's going to show you what's kind of happening. So you can see that red dot, every time I rerun the scene, it just goes to a random position on screen. So now we actually have a place for our fish to go. And very easily we can use that, go back into our process function, and instead of just having it move forward, we can have it move towards the goal position minus our current position, meaning the closer we get to it, the slower we'll move, because the closer it's going to be to 0. And now let's see what happens. If I did it right. See, there he goes. So now every single time we rerun the scene, he's just going to move directly to that coordinate. That coordinate's off screen. Beautiful. But it looks a little bit unrealistic at the moment. So what I'm going to quickly do is hop back into our 3D editor, go to our collision shape, pop our mesh under that collision shape so they're connected, and we're just going to create a reference to our body. If I held the right hotkey, which I didn't. So onReadyVar body, And this is a very appropriately named little function here. It's body.lookAt. And all we're going to do is look at our goal position, and it also wants the up axis. And now let's see how close we're getting. That didn't work. It's because I didn't put the fish mesh under there. So we're going to try that one more time. And that was working. Yeah, so now you can see every time we start a new position, his tail jiggles, he moves along to the new coordinate, and no matter where he goes, we can kind of pick him up, and he's always going to look at this one red dot. I can move him way over here, he'll still zoom to it. Move him down here, he'll zoom to it. I can move him under here, he'll get stuck. We're just going to ignore that for now. Next thing we've got to do is, if you notice, the fish is kind of swimming in the air. So the issue, somebody's got an alarm. Issue is we need to give him some water to kind of make it so he only swims there. I've quickly thrown in a little water in the scene. And this is an area node, which basically means we can just define a area in a 3D space as something else. So I'm going to add a collision shape to that. Going to add a box. Going to drag him to the generally right position. I can be a little interpretive with that. And then also on our fish, we're going to add an area as well. So area, we're going to call that the water checker. So this is just going to spout off a piece of code anytime this water checker collides with a water area. So I'm going to throw a little circle on him. It's got to be a little bit smaller. Again, just trying to fill in the gaps with my voice. Call that collision 4-4. That's the same collision layer as our water. So collision 4-4. Our water is 4-4. And now we can quickly write. We can quickly connect our signals. I should have explained that, I'm sorry. Each node can spout off signals when something happens. So for this particular instance, whenever the area connects with another area, it's going to spout off a signal, and whenever it exits the area, it's going to spout off another signal. And we can quickly say var in water. And originally I thought I'd have to make a state machine for this, but I really just want the fish to either be swimming or I want it to be flopping. So we didn't need all of that. And I'm going to connect the in water equals true when we enter the water, and in water equals false. And we'll just let that run and see what happens. So you can see something interesting is happening that we're actually going to use again for later. He is entering the water, so if I dropped him over here, he's just not going to do anything. He's going to fall right off. But you see, his coordinates aren't updating, and the issue is, as soon as he enters the water, he tries to get out of it because the coordinates are up too high. So really quickly, what we're going to do is in the water area script, we're going to redefine our spawn position. Spawn position equals self.globaltransform.origin again. Transform.origin again. Spelled it wrong again. Spawn position, and we're going to call a new generate position. And let's see if that gives us better results. Kind of. I mean, a little bit. He's kind of moving. There you go, that's a good one. Issue is, when we're generating a new position, when we land here, if you remember, we're going 1 on the negative axis and 1 on the positive, and that's for X, Y, and Z. The issue is the points can still generate far out of the water. So what we need to do is we need to damp the Y-axis just a little bit so it stays in line with the water. So in our generate position function, we can quickly write goal position.y. We're going to multiply that by 0.1. So now anytime he generates a position, you can see it's still he's still relatively in the water whenever he wants to swim somewhere. And yet we can still take him out, we can still drop him, do whatever we need with him in that moment. But the issue is I have to reset the scene anytime I want to generate a new position, so I'm quickly going to, well, my initial idea, and I'll show you because it's actually kind of fun to watch. My initial idea was anytime, because the process function runs every frame, so I was like, oh, we'll just generate a new position. Whoops. Generate a new position every single frame he's in the water. And the issue with that is frames go by quickly, nearly 60 a second. So, yeah, so he's very quickly generating tons of new positions. We can take him out, it'll stop. Drop him back in, it'll start up again. What's interesting to note about this is our spawn position's right here. If we were to move him over here, never mind, there's nothing, never mind about that actually. So now we kind of, the issue that arises there is we're just calling it too quickly. So we can use Godot's nodes again, hop back into the 3D, add a timer node, and we're just going to connect the same thing before, connect this signal right on into the fish. So now we have and you can connect these signals directly to a function if you wanted to. I'm just doing this to kind of keep things a bit more clear. And we're going to hit generate. So whenever this timer times out, we're going to generate a new position. And we're also going to need to restart the timer every time it times out. So we're going to go here. I'm going to create a reference to the timer. So timer, we're going to say timer.start. And we're going to give it a random range, just to give it a little bit more variation. A rand range of, we'll say 1 second to 4 seconds. Yeah, we'll go 4 seconds. Why not? We're going to go back to our timer. We're going to, we're going to set it to auto start in one shot, so it starts when we begin. And let's see what happens now. So he's got his position. Boom, he's got a new position. And I watched this all day for a period of my life, and I never got tired of it. I don't know what he's doing there. There we go. So yeah, we can take him out again. We can drop him over here. He's going to fall off. That's okay. That's okay. We can add a few of these guys. 1, 2, 4 is a good number. Oh yeah. I'm sorry, that's mesmerizing for me, but we'll get rid of those guys. I'm going to actually shrink them up a little bit. Never do what I'm about to do. You shouldn't shrink rigid bodies. You should just adjust the mesh and adjust the collision shapes, but we'll be fine for now. I'm going to shrink them up, and then what I'm going to do next is I found that with just, this was a very quick setup. Now we can get fish to move around and stuff, but I found that it was very easy to catch them, and the whole point of the game was like, okay, they're not going to be like super hard to catch, but the fish deserve to put up a little bit of a fight, you know? So what we're going to do next is we're going to kind of bring back a little bit that jumping that it was doing before. So very quickly in the generate position, we're going to write if randi, there she is, percent, and we'll say, let's give it a 3 equals 0. We're going to take our goal position and we're just going to add 2 to it. And essentially all this means is it's going to generate a random number in the range from 0 to 3. And if that number equals 0, plus 2 to the, I forgot the y, plus 2 to the goal position dot y. And all that means is it's got a 1 in 4, 1 in 3, computers start counting from 0. So I think it's 1 in 4 chance of giving us something special. Just like that, that was good. Because usually you have to wait a little bit. He's not going to do it again for a while. But I might just. Oh. Never mind. So with that out of the way, sorry, I'm going to move the mic. With that out of the way, we're going to save this guy as his own scene. I'll explain that in a moment. Don't look at how I've organized my folders. Charlton's already yelled at me for it a few times now. Never. So we're going to say fish demo. We're going to add W just for fun. It's going to pop into here, and now you can see we have this fish separate from our own, from our other, these are called node trees. We have this fish separate from everything else in the scene. And what that means is we can create multiple levels. We can add the same entity to it. I think in Unity it's called it's a nested prefab. In Godot they're just called scenes. And what we can do now is, if we add multiple of these guys to this scene, I'll add 3 this time. What we can do now is any update we make here, it'll update every single instance of it. So we're just going to quickly delete the spatial, the little debug red dot. You see none of them have it now. And we'll just hit play again. So now the illusion is in full effect. Oh. Ignore him. That guy doesn't matter. Neither does he. This guy does matter though. Look at him. Oh, okay, sorry. Look at him go. Okay. And now with that, what we can do is there's just one last thing we have to do, and this is for the game only. So we're just going to add one more function. We have a little bit of interaction with the fish. So it's going to be the func eaten function. And all that does is it's just going to self dot, and it's called QU free, which just essentially means delete myself. And so now whenever a fish is defined as eaten, he's just going to leave. What I'm going to quickly do now is pop our player into here. It'll make more sense in a moment. That's actually a bird. We're going to hit play. Oh, one more thing I have to do, sorry. I have to lock my mouse to the center of the screen so I can look around in a first-person view. So see, now I can look down, I can look at my bird feet, I can look at the fish that are all falling off. Please don't. Thank you. And I'll just restart again, get some more. I can grab one, hopefully. He's gone. He's dead. I can grab one, I can throw him around. There he goes. But most importantly, and this is where we end the fish AI discussion, ladies and gentlemen, I can pick him up, I can look up, and I can eat him. And that's... So that concludes the fish portion. We'll get a little bit more serious again for a moment. I'm going to quit out, hop back into our lovely presentation. So I will now make fish. We are done making fish. Ibis AM released. Well, with the fish AI figured out, it was just a matter of building out the levels, kind of making it a challenge to reach it to the end while still like making it presentable with the fish. Released on February 17th. It's on discount, I think, for the last time today. 99 cents. I think that's a little bit fair. We got some great community content with the game. People, oftentimes they'll post like glitches they find, which is saddening, but it's kind of cool to see that they're interacting with it. There's this Japanese YouTuber who just did a full playthrough through the game. Super entertaining to watch, especially when you have to turn on the auto translate. There's this really cool Ibis fan art that somebody made. Reviews have been pretty fun. This guy, after playing the game for 4 hours and finishing it, he just said, "I ate the fish." A classic. User J to the Z said, "I think this is probably what drugs are like." This is my favorite one at the end here. If you like Fortnite, then you will like this. And that means a lot to me. I'm a big Fortnite fan. But by far the coolest piece of community feedback we kind of made, and I think it was something we added like last minute. I think you suggested like 2 weeks before launch. It's the leaderboard. You can see that's me right there, number 3 in my own game. Just kind of sad and uncomfortable, but you have to understand that the 924 fish that I've eaten, that's just from testing the game and like going through and debugging it. There's a guy far above me at 2,511 fish. He's got nearly 50 hours in the game. And the reason I bring this up is because with this leaderboard kind of getting pretty competitive, a couple players were asking for just a level where there's just an infinite number of fish. All they have to do is eat. So that's quickly, I will now update this level and show it to you. I'm going to try and run the game through Steam. There's a 50/50. This is my girlfriend's laptop, so she might not even have the game. She does. Okay. We're gonna have to sit through this intro sequence. I was particularly proud of that logo animation, so I didn't want anybody skipping it. I regret that now. We're gonna boot up the game in a moment here. So you have the menu. When you beat the game, you kind of get this level select, and down here in the bottom right, this is the free roam level that I made, and you'll notice right off the bat, it's a little bit depressing. It's kind of just a flat land with some flat water. I added some clouds and birds though, if you can see those. That I was proud of. But it's really the kind of the lowest amount of effort I could put in to the game, and I felt kind of bad about it. And you see, I can try to catch this fish. I'm on the trackpad though, mind you. See, we can. Oh.
You should get it. I'm telling you.
I'm trying, Charlton. Not only is Charlton a tech genius, by the way, but he is also the only man I know that can play on a trackpad like a normal human being. So I'm going to eat this fish. You see my health bar went up. I just got the throat goat achievement for eating 100 fish. That was not planned. I'm sorry about that. But so that was the level. Oh man. We're going to quickly switch branches to the secondary branch. Oh man. 100 fish though, that's pretty decent. Switching to secondary, I made it back up just in case it doesn't.
How many fish do you have to eat to get to Glizzy Goldberg?
You have to eat 1,000 fish to. Okay. I haven't even gotten that myself to get to Glizzy Goldberg. However, we're just going to open up the free roam level and see what we've got to work with here. So this is the 3D scene of that level. You can really tell how much effort I put into it from this view. See, it's just a big flat plane. Everything's organized with these nodes. You see, I've got the land. I've got the, oh yeah, you can see all those little volume buttons. Those are fish. We'll go to that in a second. Take out the water, the environment. That's where I put, when you go underwater, everything turns black and white. That's where I put that transition. You got the light. You got the rain. That's a fun one. You got the seagulls, of course, which those are my favorite thing to look at. Let's zoom in. They're just PNGs of seagulls that just kind of flap up and down, but you never get close enough to them to know. The audio, that's actually a pretty interesting section for this game in particular, because we have the normal sound effects like the rain and the seagulls, but what we did was we created an ambience manager, and that was because our friend Cameron, who composed all of the music of the game, he made 10 ambient tracks for us to just cycle through randomly throughout all of the levels. And we were particularly mad at Cameron that day. So what we made him do was we made him create a water version of every single one of those tracks. So because the player's going to spend a lot of time fishing in this game. So meaning their head's going to be underwater. So we wanted that kind of cool transition from like the track and then the more watered down version of that. It came out really cool. So I think Cameron's forgiven me at this point, but it went good. So that's the audio. You can see I have the fish in their own separate section under the fish spawner. I'll just highlight all of them so we can see it from a zoomed out perspective. Oh man. So you can see all the fish on the map. That's always a cool view. And then we have the updates that I made. So let's quickly turn those guys on. And you can see immediately now my intention was to make it a little less barren, but at the same time it kind of made it a little bit more creepy because now you're just in this forest. And those are organized the same way. Something different about Godot with another game engine, it doesn't take there is the entity component sort of deal, but there's no the last thing, which is system. If you want to call a node, they either have to be underneath another node, or you have to do some other funky things. So if we quickly, and I just accidentally played the whole game again, so we're going to have to sit through the intro again. That's a nice logo animation.
I have a question.
Yes.
You may have said this. What's the most famous game
that was written in Godot? Is there?
Yeah, there's.
There's actually a showcase website on the Godot site.
Yes,
Like,
there is.
Set Beasts just came out on Steam. That's like a Pokemon clone.
Oh, nice.
There's a couple other ones. They have a big showcase video up there.
There's also a.
Like if you just bring up the webpage while that's loading, like you can.
Oh, it's loaded. We're already in. We'll hop onto the webpage after this.
Yeah. But
yeah.
they have a whole showcase website that shows that.
Yeah.
I was looking that up earlier.
Yeah, so see, now we can walk through a forest, and if in the trailer you remember this hand guy, I'm going to try to end my part of the talk cinematically and give him a fish. We're going to see how that works, though. If I can get one. Oh, man. See, those coordinates are definitely generating. All right, now we're going to try to pass it to him. I might need to call Charlton up. Oh, no, he's got it. He's got it. And there you go. And there you go. So if we're happy with that update, some of you might not be, but I'm happy with it. We can just ship those updates to, and this is where we're going to transition into Charlton here. We're going to call it free roam hand. And we're going to commit. Push origin. Okay, I'm happy with how quick that went. And now we're going to go to Ibis AM. We have to merge the branch, don't we? I'm not as familiar with GitHub as a lot of you might be, so we're going to call this the free roam stuff. I'm going to create the pull request. Whatever that word is. Since there's a conflict, can I just ignore that, or do I have to?
I will have to walk you through merge conflict resolution.
Trust-based development.
There you go. Okay. But then essentially after we merge the branches, we'll go back to the main branch. And all I need to do, I'm on the main branch, all I need to do, this is what Charlton set up for me. I just need to draft a new release, and we'll call it, what version are we at? We're at V 2.0. I'll just say 10, who knows? Choose a tag. Oh, we have to give it the stable. Oh, he would have killed me. You have to give it the stable tag. Stable, dash stable, enter. And now the release is live. And Charlton, if you want to come up and dissect what's going on, that'd be great.
Thank you, Kevin.
No, thank you.
Okay. Let's see. There we go. Let's get back into the slideshow. If Embark's Wi-Fi works, I do like that. Okay. So this is where I come in. So obviously Kevin and I are like just two people, right? And when you're releasing a game for multiple different like desktop platforms, I'm just gonna fast forward through like everything that Kevin did here over the past like 30 minutes or so. There we go. Cool. So when you're just two people and you have like 3 different versions of your game that you're maintaining on multiple different platforms, on multiple different storefronts, on multiple different release channels, because we do a stable and a beta release, that's quite difficult because, you know, a single person, especially when it's a one-man development team, because I don't actually contribute to the game at all, his time is very valuable, right? We don't want him wasting time on anything but, you know, working on the game. So if you think about, you know, maybe it takes 5 to 10 minutes to do each of those individual release processes, or even just the builds for those, like we're talking about, you know, maybe 30 minutes to an hour of just Kevin sitting down, you know, monkeying around with building, which is a waste of time. So luckily he has me. I'm a, you know, very good friend of his, and I also work at Xspirit, which is a global DevOps consultancy. And at the time that we were collaborating, I was learning all about GitHub Actions. So I'm going to tell you all about GitHub Actions. I'm going to talk a bit about CI/CD pipelines for game development, the things that I learned because I didn't have a background actually in game development before I approached this particular project. And then we're going to do a bit of a deep dive into the pipelines that we built to release Ibis AM on Steam and itch.io for our stable and our beta releases. So let's talk first about what our end goals are. So we want to have great experiences for developers, and we also want to have great experiences for our players. Players want to have stable, well-tested games, that they can assume are going to work on their machine, no matter what type of machine they have. It really sucks for myself. I have a Mac. When I go to Steam and I see that there's a cool game, but I can't actually play it because it's only built for Windows, and the developers didn't take a little bit of extra time to get their build processes working for Mac. Not that I have anything personal against those people, but so that's the great player experience. Then the developer experience, as you saw, just a few minutes ago, Kevin just released that game update, on 2 different storefronts, just by clicking a couple of buttons in GitHub. He didn't have to do anything really involved or technical. He just clicked some buttons in the UI, and then my automation came in and took care of the rest. So how can we ensure that Kevin has a great and easy experience, and also ensure that we have consistent and fast releases of all updates for this game on all of the platforms that we support simultaneously, and maybe more if we decide to expand the number of platforms we support in the future? So let's talk first a bit about GitHub Actions. So GitHub Actions is a generic workflow engine. It's built into GitHub. It's a feature of GitHub's repositories and so on that lets you automate all kinds of different parts of your development process. Now, in many cases, you may apply that to CI and CD, but you can actually do all kinds of other really neat things about it. GitHub Actions is based around these workflows. These are text-based files that you write in YAML. Actions themselves are these reusable building blocks that you can share between different repositories or take from third-party sources across GitHub. You have jobs, which are collections of steps, and I'll show you kind of the hierarchy of the different components of Actions workflows here in a second. And then a step is just a shell script or something that calls an action. So to kind of visually map it out, we have this YAML workflow definition for a pipeline, if you will. And what this looks like visually is we have a job, so this guy's a job, and then we have steps inside of the job, and each of those will perform a particular action, if you will. So this will check out the code of the repository, install Node, and then run bats, which is like a piece of JavaScript tooling. There are 37 different triggers that you can actually call or have run your actions workflows. So whether that's just manually going in and triggering it, or in the case of what we did with Kevin, he creates a release on GitHub and it triggers our workflow. Pretty much anything that you do with issues, pull requests, etc., and many other things in GitHub, you can have trigger workflows to do all kinds of nifty automation. So you may be wondering where all of this actually executes. So on GitHub's Actions kind of platform, everything runs on this runners idea, and that's literally just an ephemeral server that is spun up when your job is queued to run. And it basically, you get this fresh instance of a server that comes online just for you, just to run your little job. And then once your job is done, it goes away. So these are hosted on Azure and they're managed by GitHub, so you don't actually have to do any kind of infrastructure management yourself. You can literally just focus on writing your jobs, which is quite convenient. And there are hosted environments, so for Linux, Mac OS, and Windows, no matter what tool chain you're using on what platform, say you're building iOS apps, you need all of the iOS development tool chain that can only run on Mac OS. In our case, we do everything on Linux. Maybe you have stuff that you're releasing for Windows that needs Windows-specific build tools. In any of those cases, you can run your jobs on whichever of these platforms suits your needs. You get live streaming logs coming out of Actions. I'll show you what that looks like in a second. And there's a ton of pre-installed software that GitHub provides in these runners that, most languages and frameworks and tool chains, like there's a lot of the common cases that things that you would need are just installed by default on there. So there are different specs for runners. The default configuration for Windows and Linux is 2 CPU cores, 7 gig of RAM, and 14 gigs of SSD space. For Mac runners, it's 3 cores with 14 gigs of RAM and 14 gigs of SSD space. And there's also, this is now generally available. You can get larger runners to run jobs with more resources. And the pricing is actually pretty cheap. There's a generous free tier. The way it's billed is with minutes. So the less minutes you consume, and if you're not using more expensive SKUs, then you can actually do all of your different pipelines for free. But if you need more than 2,000 minutes or more than 10% of that, if you're doing things on Mac instance, because it's multiplied, it's more expensive for Mac OS in particular. So game development, it's very unique. So if you have a background in other types of software development, many of the things that you saw that Kevin demonstrate up here would be unfamiliar to you. I mean, I know the first time that I saw it was kind of like looking at a plane cockpit, and there's all these little knobs and switches and lights everywhere. Nothing that I had ever really seen. You also have some complicating factors. So there's large assets, you've got all these media files, you've got 3D meshes, you've got audio files, etc. The tool chain is fairly complex because depending on the engine that you're using, you have all of these kinds of bespoke tools that you have to make available for the game to actually be built and packaged for the different platforms you're targeting. Build times are typically fairly long, especially for like larger engines like Unreal, for example. And it's also super native centric. So you have to build for native like platforms for each of the ones that you plan to support, and there's different customizations you may have to make to get your game running well on Windows versus getting it running well on a Mac, for example. You have a diverse range of different hardware that consumers may be using, and you have to plan for that accordingly when you're thinking about how you handle like performance. If someone has like a cheap laptop versus like a top-of-the-line one, you want to have a generally good experience for everyone. And there's all kinds of really intricate difficulties with storefronts because as it turns out, every storefront has its own unique set of tools that you have to use to actually upload the files to them and make them available to your customers. So you saw this game engine kind of IDE environment. They're very special and they're not really well suited to version control. So even though we're using Git and GitHub, the kinds of diffs that are produced when you change stuff in the game engine's UI are not necessarily meaningful in the same way that like if you're actually in kind of a code base that's not like a game engine, maybe you're working on some sort of web application or something, like that tends to be more structured and intentional and like human readable, whereas this, it's like you change a mesh, it's like a giant thing that there's no way for you to actually look at and reconcile. So refresher on the challenges. We have a small team with limited resources. This is a 99-cent Steam game. Like, we're not banking here. We have 2 people. We want to manage the complexity and the cost. We want to make it as easy as possible to release the game, but we don't want it to be like, $5 every time we do a release or something ridiculous. We have a bunch of different platforms and storefronts that we're trying to manage releases on, and we even want to make add support for different game consoles and things as well. And we don't want the complexity of our release process to increase every single time we add a new platform. We want things to be consistent and reusable. We want to ensure like a quality experience for players, and we also don't want to have an insecure kind of build process where we have no idea what's in the sausage that we're throwing at players, right? Like, we actually want to know the things that we're bringing in. But yeah, scaling this is hard. You have to think about like the number of builds times the number of stores, and then add on top of that the number of different console releases we're doing. Like this can go up quite quickly, even with the single storefront, right? We want to add, for example, the Epic Games Store. That's another 3 releases on top of the 6 that we're already doing from Steam and itch. So anyone can deploy, and we want to just make this whole process easy. So this is what success looks like from my point of view. This is what Kevin texted me. He said, "It literally feels like I'm cheating, only having to click like 2 buttons and having it do everything automatically. If your job doesn't think these actions are fantastic, I'm gonna need a word with them." So this is very good. I wish I had like an IMDb page or something, it's like I could put that up. So let's go ahead and dive right in to our different actions pipelines. So I will make this a bit bigger and easier for you to see. So can everybody see this okay? Okay, great. So I can't, my screen's not being mirrored, so I'll have to like spin a little bit. So you see these guys with the spinny yellow-orange dots next to them, and then you see all these green ones. So we're looking at the Actions tab of the Ibis AM repository where we store all of the code for Ibis AM. And all of these are different instances of the workflow that builds the game executing. So here's the list of workflows that we actually have inside of our repository. So this one is specifically building and releasing the beta channel of the game. And then we have 2 additional workflows here that build and release the stable channels for itch.io and Steam. Down here we have a workflow that will lint and format the GD script source code of the game. And then we have this guy that actually runs every time new code is pushed to the repository. And we basically use this to see whatever's at the current commit, does that actually build? And if we want to play test that, we can actually click in and grab that. So here's a completed workflow for that build branch tip run that was pushed 14 minutes ago. And we can see that this ran for about 10 minutes. So that's another thing that I would like to talk about. So down here you see that this one ran for 20 minutes 4 days ago. And then after this one succeeded, the rest were, say, about 12 minutes. So there's this function in GitHub Actions called caches. And there are some intermediate things that we have to create specifically for our Mac OS builds. And if those are not already built where we can pull them out of this cache and reuse them, it adds about 10 minutes to the build process. So to cut costs and also shave 10 minutes off of most of our builds, we actually take the Mac OS toolchain that we're using to build the native Mac version and keep it in this cache, and that helps us save a bit of money and also make that process a little faster. Now, if I click into this particular workflow run and I scroll down, you can see that we have this little section down here called artifacts. So this is a built-in, almost think of it like a file storage, like cloud storage thing, specific to each of your workflow runs. And you can see this one only has a build for Windows and Mac OS available, and we can see the sizes for those. So we only do Windows and Mac builds on this guy because Kevin and I are only ever testing it on a Windows or a Mac because we hate Linux. Not actually. But if I click on, say, this stable release, so not this one, I want the stable Steam channel, you can see this should have already got, no, it has actually gotten through the build game process, great. So if I go up to summary, that's not going to be done until this entire thing is completed. But let me talk you through this graph that you see. So we have a build and a release stage of our workflow. So the only thing that's different between the different storefronts that we're releasing the game on is the release step. So the build step is actually identical for the most part between Steam and itch, and even for that one workflow that we saw that's taking whatever the current commit is and pushing it up for Kevin and I to test. So I can click in here, I can look at this section, and this is all of the log output that's produced from this run build step. So that's a lot of log output. And now I can click over here and actually watch the process of it. It's uploading it to Steam right now. So this is the output of the Steam command, which is the tool that Steam gives you to upload new artifacts to their depots so that players can download them. So we're watching this happen right now, and it actually just finished. So it just finished the upload to Steam, and now I've got a nice green check mark. And if I click back over to the summary and I scroll down, now I can see here are copies of the artifacts that we released to Steam. So if I wanted to grab, say, the Linux or the Windows build that we just shipped, I could do it here, or I could actually do it from Steam as well. So let me show you a little bit around the workflow file, because this is where all the magic happens, if you will. So if you've ever written YAML, this should be not scary at all. But workflows, they have a name, they have a trigger. So in this case, anytime a release is published, Ignore the concurrency group for now because we'll come back to that. And then these are just environment variables, so the Steam app ID, and then we give it a build version that we take from the tag that Kevin put in. And then here's our list of jobs. So we have this build game job, and you can see, we check to see if the tag name of the release contains this string stable, because Kevin and I want to just have an easy way to essentially say, like, if this is a stable release, we want to ship it out to anyone who's not on the beta channel. And if we don't put that special string in the tag name, then it goes on the beta channel, and then all our playtesters can easily access it, but it'll still run the same set of steps. So I've got this sort of master build Godot action here, if you will. And this guy is like a giant reusable workflow maintained in a separate repository that handles all of the different steps of the build process. But to make it easy for us to maintain inside of our repository here, we don't take all of that complexity and put it in the workflow file. We move it out into a separate thing that we can bring in and reuse. So if we look at a different workflow file, say for maybe our itch release, I'll click over there, and I want to click on the workflow file here. You can see that we're using the exact same action to run the build, just with a couple minor changes in the set of parameters that we pass in. And the reason that we have some configurable parameters is because, for example, when we're building for itch, we don't want to include the Steam SDK, which is the nifty thing that lets you get the achievements like Throat Goat and so on that we've built in, or the leaderboard and so on. That would not work for folks that are running it with itch. It would just crash. So you can see we've got our build step, and then we've got our release step down here. And each of these are specific to the storefront that we're working with. And I can actually show you, so if I say grab this and go up here and work with this very small text, get rid of that space. So this is a separate repository where the releasing actions are stored. And I can say click on this itch action, and here is all of the code that's related to the process of publishing the game on itch. And you can see that's a bunch of like extra steps. So it's much cleaner to just maintain that separately, and then we can just bring it in wherever we need it. This is what Steam looks like. And there you go. So yeah, it's we have a bunch of these different pipelines. If I click over here, so we have like 24 different repositories, and if I click this CI tag, all of these that are tagged with CI are related to different stages of our build process, or they're a dependency of the build process in some way. So if you want to play around with this yourself, I have this public repository that I created called CD Playground. And this is a basic first-person shooter starter template that you can grab from the Godot Assets library. So you can take this repo, you can fork it, play around with it in Godot, and then we have a set of workflows inside of this that are the same set of workflows for the most part that you see in our actual game that we're building and releasing. And once you start making releases and so on in your copy of this repository, you can trigger all of those different pipelines and play around with it as well. And let's go back here. And I also want to show you the actual build workflow as well really quick. So this guy is big. He's like 200 lines, and he calls into a bunch of other workflows as well. So yeah, definitely easier to maintain this separately than have it embedded in each one of our different workflows that does a build. So that's the abbreviated version of this talk, because I don't want to extend it too long past what Kevin has so graciously shared with us. But Kevin, if you come up here, let's go ahead and maybe take some time for questions.
Yes, sir.
Yeah, we'd sit in the chair. Right on. Hello, everybody.
Guys,
Any questions?
to answer your question, before,
Yeah, for the most popular game on the Godot. This is kind of a cheat answer, but there was a Sonic game that uses a heavily modified version of the Godot engine for, I think, a Switch port. But yeah, so that was
That's pretty cool.
Rotato is another.
Rotato. Yeah.
Yeah, that's another big name.
Hey, what's up?
I know you got a bunch of repos with all of your individual actions. For building Godot, for publishing to itch, were there existing actions out there, or did you have to like fork them and tweak them to work for you?
Sure. So there were existing actions for like individual uploads to Steam or to itch, but I took those and I built additional steps around them to say automate. So my kind of theory of how I approach these things is I just want things to be as automatic as possible and ultimately source their configuration from the types of configuration files that the developers are actually using. So in this case, we source all of the information about the platforms that we're targeting from the build config file that Godot uses itself. And in order to gracefully handle that, if I go back to, say, the repo that's responsible for releases, which, let's go back here. I'll show you exactly what I mean. So here, Kevin's working on some new games that are very exciting. And let's go down to release. Nope, that's the wrong release one. Where is the release game? I can search for it. Pro tip, if you're ever presenting, take 10 seconds before you get on stage to turn on the mirroring. Oh. There it is. So release game. So I can go to itch, and if we look at this workflow, you'll see that what we do is we actually download all of the artifacts associated with the previous step. And then I just run a little bit of shell to test which of the artifacts exist in that set that I downloaded. And depending on which in this set actually exists, then we run all of the individual release steps for those different platforms against those artifacts. So in this way, I can use this with any arbitrary Godot project that Kevin makes, and I don't have to manually set anything. It'll just source the information it needs essentially from the build process, which sources everything that it needs from the config files that are used to build the game.
Nice.
Yeah. So a lot of these things are like supersets of other actions that we pull in. I did have to very heavily modify. There's a particular action that I use to set up the macOS cross-compiling toolchain. So we actually do all of the builds on Windows to save like a ton of money. If we were running our macOS builds on Mac, which would be the easiest way to approach it, it would be quite costly. So I spent like several days just working on getting the tools that we need to build Mac versions working in GitHub Actions and like perfected. And I don't know, that was mostly just for me. We've only sold like 30 Mac units, but like, so like 400 plus Windows units to maybe like 30 Mac units, and then like another 20 something Linux ones. So, but it was worth it. That's a non-trivial percentage, even if it's like single digit. It's important to me.
It's important to me too.
So any other questions?
Does Godot have the ability to run like data on what the players are doing, like maybe where they're getting tripped up, or
Oh, like telemetry?
I guess like maybe areas where there's issues with the game, like not a bug, but where the player is just having some trouble. Like, are you able to run data on where you can maybe see like player sentiment? I don't know what you would call it, but maybe where like
So we are looking into that. I was going to write like a small GD script library for Kevin that basically fires different Google Analytics events depending on if people clear an area, a level, or if they're maybe like you fire one when people start the action to like eat a fish, but like fire another one when they complete it. You can basically see like are people having trouble with different mechanics when you correlate those. I haven't gotten around to doing that, because I have a real life that doesn't involve $1 games, but that will happen at some point. But yes, to your point, let's talk a little bit about like our process for like iterating on the first couple of versions, because we learned some things once it actually got in people's hands.
Yeah, there was, day one, even when we were showing it off to our friends at their house, we were already finding bugs with the game. So, which made it very important for me that the next morning, and that's why this build process was so important. It was just because the next morning I could just wake up, I just move a couple collision shapes around, and then just send the update off, and then just enjoy the rest of my day. I didn't have to make a whole thing about it. One way we kind of cheated getting kind of analytics was there's a few like level specific achievements, so we can check if like a player made it to a certain level, you know, and see how far they got before, you know, presumably they got upset and just turned it off. But yeah. Cool.
And we've shipped a lot of updates. So we've actually shipped like 43 updates to this game since we released it. And it's really just because the actual process of like shipping changes is so streamlined that we can react really quickly to player feedback and make things easier or improve different levels and so on. Like that, apart from just removing a lot of the like manual drudgery of having to do the build process, like it really does significantly accelerate your development cycle, and like you can do all kinds of things really quickly. Very cool. Yeah.
And think about how much money you've saved on Mac builds.
Yes. They really charge an arm and a leg for that.
I think I was charged like 39 cents last month.
Yeah.
Is it 3x or 10x?
10x.
That's what I thought.
Yeah. So I could go for like another 45 minutes about like all the cost optimization stuff that I did with these workflows and like how we do things like concurrency control and artifact retention and stuff. But I don't want all of you to fall asleep. So unless that's like really specifically, you know, you work with actions on a regular basis, like you can come to a different talk of mine about that.
How are you managing your graphical assets and sounds? Like, are they in Git? Because I know
Yes.
with Git, are you
I want us to use LFS, but it's still on the legacy like data packs billing model. It's not usage based.
Okay.
Usage based, but they are migrating to that and go GA this year.
Like I know you're probably just loading a folder with the Godot engine and stuff, but
Oh,
like,
yeah.
are you pointing like your graphical tools at it too? Like you just edit the models, or you edit textures and just save it and check it in and don't worry about it? Is that like your process?
Because I work as a 3D animator normally, so it's always like I'll get a model or I'll make a model, make sure it's optimized before I bring it in. But on the GitHub side of things, I just kind of just shoot it up there and just let Charlton deal with it. I don't think about it too much, and I should.
I do at some point want to write like a Godot plugin that will run kind of like an asset optimization pipeline of some kind, but I have no background in any kind of 3D modeling stuff, and so I'm just like, let's just focus on like getting this thing to people so they can play it first, and then eventually I'll learn more about how all that works. Awesome. Any other questions? Yes, sir.
So you have 3 different builds. You have a
Yeah.
Mac build, Linux, and Windows.
Yes, sir.
So do you develop just on like on 3 different machines to create the builds, or just?
So we actually don't have to, because Godot, the development environment, when you're working in that, it's all cross-platform.
Okay.
So you can work on your like version of the game, like the version that you see in the Godot editor is like the version of the game that it's going to build for the different platforms. You just tell it which ones to target, and then it will do the build and release process for those.
Okay.
So, I mean, we never actually did any playtesting on all the different versions. Like, I think we did it on Windows and Mac, and then we just kind of like, well, 2 out of 3 of them worked, so we'll just cross our fingers that the Linux people won't have trouble, and they did have trouble. We had to quickly patch that.
Other than that, it was fun. Linux was fun.
Which level was the most fun to make?
Which level was the most fun to make? this was one of my first games, so like each compounding level was my favorite level just because I was getting better at the game. There's this one level though that's just all black, and there's a light fish there, and you kind of have to, because there's in the game there's obviously your goal is to eat the fish, but there was with this one level it was kind of nice because you actually had to carry this light fish with you throughout the level, and I just thought that was a kind of nice thing that you didn't have to eat the fish completely for once. Yeah, so I'd say that level is.
Which level number is that?
It might be 4 or 5.
4 or 5?
Just take a wild guess.
Oh, it's
4
over
is a
here.
good one too. That is my favorite soundtrack. Cameron made.
Yeah, Cameron's a legend. He's here with us. He's the guy that looks like he's currently in Led Zeppelin. Yeah. Yeah, sure.
So, I know you said it's one of your first games. Did something prompt you to get into creating games, or is it just something you've always wanted to do?
Yeah, I think it was because once I started getting into 3D, I did graphic design in college. Once I started getting into 3D, it was like I was like, oh, this can happen, you know. And I didn't have any programming knowledge, so obviously I went with Unreal Engine at first because at the time it was being talked about a ton, and you can use blueprints so you don't have to code. And when I hopped into that, it's like I just floundered around and I couldn't get anything done. And then like one of my favorite game developers, they released just a course on Godot, like just a whole like make your first person shooter course. And I was like, yeah, I might as well try it. What is? I was like, yeah, I might as well try it. And then then it just started compounding from there. Obviously, I had a ton of failed projects before I finally finished one. But yeah. I've only finished 2 games, but I've made a few that are just sitting on my machine. Not good games, of course. They're not good at all.
I didn't realize you submersed this entire level.
Yeah, that was see, that's something fun I can do. I can just kind of, if I'm just feeling a particular way one day, I can just completely change the level and then just hit 2 buttons and I don't even have to think about it. I can't think about if it's a good decision or a bad decision. I can just do it. The fish, yeah, that's one thing I didn't talk about. They can also jump out of your hand. Just give them a little bit of a chance.
If you peck them enough, do they die and stop squirming?
No, not. In a new game that I'm working on, it's a cooking game. You can chop the fish's head off and then they stop wriggling around. But they've been going through enough in this game.
Which one?
Exit.
Which level?
I think it's 5. Yeah, so this is the level. It might be a little bit hard to see on this screen, but you see there's this fish that glows. You can grab him, theoretically. Grab him, Charlton.
I'm trying.
Get good.
It's better. It's a challenge. And yeah, then you can just take him through this tunnel or throw him forward. Yeah, see how he's bouncing around like a flare?
I love the tunnels. Cool, yeah.
It was probably the easiest level to make because everything's just one texture and just like colors.
I go down here.
You don't have to play. The game is it's admittedly it's one of my first games, so it's not that great, but it's a very slow game. So
Let's show him the first one though. Or no, it's the second one, right? Is the Black Forest?
no.
It was the first one?
Yeah. This is an interesting one though.
Oh yeah. So this one you have to like collect fish and then you go out here. And you actually have to like jump down on this hand. Yeah, and then you go in here. So the secret to this is you have to collect a bunch of fish and then pile them onto that hand. and move them in here. It's like a puzzle.
Yeah.
And so he needs 3 fish. So you have to put him down here and feed him 3 fish, and it'll let you through. All of this can be yours for 99 cents.
Only for today, though. It goes to $2 again tomorrow.
You didn't bring any.
Oh,
You're dissing me now?
The players. So this is one thing. In the playthroughs we watched, they would just they wouldn't get it at first. Obviously, they just walk down the tunnel, run down, and then they would just kind of sit there. And my thought was, yeah, then they'll die, and then they'll go back up and they'll be like, oh, I should bring fish down this time. A lot of them just got frustrated because they just had to wait like a minute and 30 seconds instead of like resetting the level. So I added that in there just to persuade them a tiny bit.
But yeah.
Right on. All right, everybody. Thank you so much. Any other questions?
When can I play it on my phone?
It's coming. It's
Okay.
coming.
If I really want us to do a mobile release, which is actually something that you can do with Godot. We just have to think about the way, like the control scheme, basically. Like, do we want to have kind of like a virtual joystick to move
I
the
see,
head
where you
around,
move
or do you
it
want to use
around
like
on the
the
screen?
tilt on
Yeah.
your phone?
Oh yeah.
Those kinds of things.
Uh-huh.
Yeah,
Some people mentioned doing it in VR as well, which would be
that'd be great because you have to like all the time.
I see the next Angry Birds. That's what I see.
It's the next Angry Birds.
There you go.
That's dangerous.
Oh, it's a 212. Sorry.
Awesome. All right. Well, if there's no other questions, thank you guys so much.